Hey guys, welcome back to another video with Math and Physics Fun with Gus. Today, we're talking about electric fields, Coulombs Law, why electric fields are important, and this is actually my first lecture in a series of lectures of a really fun topic, electromagnetism, and I'm so excited. So, let's start by talking about Coulombs Law. Coulombs Law gives you a force, and it gives you the force between two charged particles, and that force is equal to 1 over 4 pi epsilon naught, this is sometimes written as K, times the charges of the particles involved, so charge 1 times charge 2, divided by the radial distance between those charged particles squared, and then this is the direction of the force in the end. I'm not going to talk about too much about this, it's not that important in this video, but I will do an example about how to find this in the end. So we then say we can rewrite this as equal to Q times the electric field of one charge on the other, which is this would be, because this is big Q, so the electric field of the smaller Q. So the electric field is written over here. Now the script R, we'll talk a little bit about it real quick. The script R vector, right, which gives you the vector difference between the point location and the charge location. And then you can find this R hat by taking the script R vector divided by its length. So say you have a ton of charges. You have many charges. You want to find the total electric field at some point. You just sum up all the charges, the direction that they present at that point, divided by the length away from that point they are. So then to find the total force, you just say the force vector is equal to the charge of interest times this total electric field. So let's do an example. So example 1, we have two charged particles, Q1 at the origin and Q2 some distance a away from the origin, and we want to find the electric field at P, which is some distance on the x-axis. So let's do this. So from here, so some distance x away from the origin. So to find the electric field, we can use, right, the sum, but the sum only goes to 2. So we can rewrite the electric field as just the sum of 2 electric fields, so E of 1 plus E of 2, where E of 1 corresponds to the electric field of this particle at this point, and E2 is the electric field of this particle at this point. So we know we can write this as 1 over 4 pi epsilon naught times Q, well it's Q of 1, divided by, and I'll write this as script 1 squared times the direction it points in, 1, plus 1 over 4 pi epsilon naught Q2 over the radial distance of the second one from the point of interest, and then the direction it points in to. So now let's put in the information we know. Well, we have this here and here, so we can factor 1 over 4 pi epsilon naught out squared. Then we have Q of 1, and this, well, think about a charge. It points, has electric field radially outward, right? But since it sits perfectly at the x-axis, the radial direction at this point is just in the x-hat direction. So we have that this points in the x-hat direction. So I'll write that like that. And then the radial distance is just from the origin to the point, which is just x. So it's the length squared is x squared, plus, now we have Q2 over the radial distance between, remember, the charge and the point squared. So we have the distance from the origin is x, and the distance between the origin and the second charge is a. So that means this distance here is x minus a. So that means the radial distance squared is x minus a squared. And then we see again, or how these work, every point's radially outward, points again in the x-hat direction, since this sits perfectly on the x-axis. So we'll write this as x-hat. Okay, so now we can write this as 1 over 4 pi epsilon naught times Q1 over x squared plus Q2 x minus a squared, and it points in the x-hat direction. And then we just found the electric field at this point. Okay, let's do another example. So this is our next example. Now we have the point charges in between these two charged particles. So we're going to, again, have the electric field is equal to E of the first charge plus E of the second charge. And again, we're going to go straight to where we have the 4 pi epsilon naught factored because they're both point charges. Q of 1 over the radial distance of 1 squared times the direction that the field points in. And then Q2 over the radial direction squared of the second point charge. And then the direction the field points in. So again, we have that this distance, x. So this is again just x, right? This from here, here is x. So we'll say 1, 4 pi epsilon naught q1 over x squared x hat plus. Okay, now we have the charges here. So from the q2, we draw, our radial lines because it's a point charge. It points in the negative x hat direction. So this unit vector is negative x hat. We'll put the negative in the front. So we're going to have negative q2 x hat. Now let's find the radial distance between this point of interest and the point charge. Well, that's just a minus x, right? So if you want this distance here, it's going to be a minus x. So it's a minus x. A minus x squared. And then again, so I found the electric field of it in the center. Okay, so now we're going to show the unit vector r hat 2 between q and p in example 2 is in the negative x hat direction. So I kind of just said, okay, let's look at it. It points here. But now we're going to show it's in the negative hat direction. So we know that script r hat is equal to script r vector over the distance. And that's also equal to r vector minus r vector prime over the distance. Right? And we know that distance is just going to be a minus x, as we saw up here. So it's going to be a minus x. And so the distance between this and the point, that's x, minus r prime, which is from that to the charge, which is a. And this is in the x hat, both, right? But we know that a is greater than x, so we can write this as negative a minus x over, again, a minus x in the x hat. And this is just 1, so you get minus x hat. X hat. Okay, so that's all for the video today. I really hope it was useful. Please like and subscribe.